Hello, I'm Mrs. Jacobson, and today we're going to cover in Module 10 and 11 the two-story problems. And the first one is max or min of a quadratic function. A medical equipment industry manufactures X-ray machines. The unit cost, C, depends on the number of machines made. If X machines are made, then the unit cost is given by C of X equals this function. What's the minimum cost? So when you look at the function, we have this. We know it's a parabola because it's x squared, and we know it's going up because this is positive. So the minimum value would be the vertex. And they want us to find the minimum unit cost. What is the minimum unit cost? So to find the number of units that will give that minimum cost, you need to find the vertex. Negative b over 2a. Remember, this is your a with the squared term, b is with the x, and c is the constant. For these problems, we don't need c to find x, at least. $224 divided by 160. They want the unit cost, so we need to find C of X. This is the number of machines, 160 machines. And you just plug that in. 0.7 times So the total cost for 160 machines will be $10,536. Do one more. Let's do a max. Okay. A ball is thrown vertically upward after t seconds. Its height in feet is given by h of t equals 120t minus 16t squared. And we want to find out after how long will it reach its maximum height. So we want to know the time that it will reach its maximum height. We know it's a parabola because it's squared. We know the parabola is going down because it's negative. So the vertex would be where we'd hit our maximum. So we have t equals negative b over 2a. When we plug that in, we have, remember that a is with the squared term, so a is the negative 16 and b is the 120. If you needed c, c would be 0 because there is not a constant. So negative 120 over 2 times a negative 16 equals 120 divided by 32 is 3.75 seconds. They wanted to know how long it will take to reach the maximum height, so it's 3.75 seconds. If they wanted the maximum height, you would plug that in for t. So we plug that in, 120 times 3.75 minus 16 times 3.75 squared. 225 feet. Height was in feet. So these problems for max and min are just finding the vertex of the parabola. Just be careful what they're asking for. If they want the number of machines, you stop here. If they want the cost, here. If they want time, you find t. If they want the height, you plug it in. Okay. The other set of story problems are these. These ones, most of them, I think you're using area and perimeter, and then you plug one into the other to solve. Lamar has 116 meters of fencing. He will use it to form 3 sides of a rectangular garden. The 4th side along the house will not need fencing. So he has a house here. And they said that this was x. So we'll give this other variable a y. Find a function that gives the area a of x of the garden in square meters. And they only want it in terms of x. We know, the way I've drawn it, that area is length times width, or in this case, x times y. They gave us how long the fencing would be. It's going to go around here. So the 2x plus y equals the 160. But for part A, they want it in terms of just x. Oops, right here's the x. Right there. So we need to get rid of the y. Well, we can solve this for y by subtracting the 2x to the other side. And then we can take this and plug it in for y. Then we have it in terms of x. Distributing the x, we have a negative 2x squared plus 160x. So that would be part A. B says, what side length x gives the maximum area? Well, this is a parabola. It's going this way, so the maximum would be the vertex. And so x equals negative b over 2a. B is 160 over 2 times a negative 2 is 40. So x equals 40 would give us our maximum, and that's in meters. To find the maximum, which is the next question, we plug that into our area. negative 2 times 40 squared plus 160 times 40 is 3240 meters squared, or square meters. Let's try one more. A school wishes to enclose its rectangular playground using 120 meters of fencing. Suppose that the side lengths in meters of the polynomial is x. So we have x, x, y, and y. Find the function for the area. Well, we know area is x times y. And we also know the fencing, the 2x plus the 2y equals the 120 meters that we have. Now we want to put it in terms of just x, so we need to solve for y to get rid of it. So solving for y, subtract the 2x. And then divide everything by 2. So we have y equals a negative x plus 60. Then we can plug that in here. Now we have it in terms of just x. So that's part A. Part B wants us to find the maximum area of the playground. Well, the length x that will give us the maximum area. This is a vertex because it's a parabola going down, so the vertex is the max. Part B then, x equals negative b over 2a. I think I started copying the other problem. X times x is a negative x squared. And the next one is only 60x. Careful, that should be 60. Negative b over 2 times a. 30. So this side needs to be 30 meters. To find the maximum, you just plug 30 into your area. Okay, I keep getting a different answer. Negative 30 squared plus 60 times 30 is 900. Okay, that's right. So that's all there is to those.